All right, today's session, what we're going to talk about are temperature extremes and what type of hazards are created by thermal stresses, and a little bit about how we go about measuring it and controls that we utilize. We'll start by talking, when we talk about thermal stress, there's two types of environments that we can deal with. One is the extreme hot environments. That can result as being in the part of the country you're in and your ambient air temperature exposures. And it can also occur in your actual several industries where you have hot processes taking place, such as in foundries and where there are furnaces and things like that. The other type of thermal stress that we can encounter are cold environments. Again, you can encounter those in the ambient air environment, depending on the location where you're at and doing the work, and whether that work's being done outdoors. You can also have cold environments indoors, where you have freezers and types of industries where you need to keep the environment extremely cool for the process of what you're doing. Example of some of those types of things would be in your warehousing facilities for grocery stores and things where you've got food products that have to be kept at cold temperatures from between the time of storage and before distribution to the end use. So we're going to talk about both of those heat and cold environments today. We'll start off by talking about hot environments and and what results from hot environment, and those are going to be basically heat stress conditions. As I'd mentioned earlier, the primary work environments that you can encounter hot environments are things like foundries or in boiler rooms where you have furnaces, on ships where you have large fuel or furnace areas that are used to propel the ships and so on. A second is you're actually working in the ambient environment where you're outdoors. Here in the Southwest, if you're located in the Southwest, where temperatures can get up during summer months in the 115 degrees, just working in those ambient environments create a body burden from a heat stress condition. And of course, a secondary source that contributes to your overall heat stress condition is going to be the metabolic heat load that your body produces from doing manual labor and excessive or extreme exercise that creates internal body temperature. So when we talk about metabolic heat, what we're talking about is the heat load that your actual body can create. And then finally, a third source would be where we have situations where we have to wear protective clothing, personal protective clothing. You may recall we talked about the various types of body coverings, from disposable coveralls to non-breathable coveralls to fully encapsulated suits. Some of the areas where you might encounter these kind of environments could be in your hazardous waste cleanup sites, during asbestos abatement or lead-based paint abatement projects, or hazardous materials cleanup of spills and of various hazardous chemicals, from solvents to mercury and so on. So those are the types of conditions that can create a stressful environment from a heat standpoint. When we go about evaluating heat stress conditions, there are some environmental factors that come into play. And primarily, there are 4 environmental conditions that we need to be aware of. The first is just your air temperature, your ambient temperature in the outdoor air. The second would be the radiant heat load or radiant heat exchange that takes place, and that's induced by exposure to the actual sunlight. The third is going to be air movement or wind, and finally humidity plays a factor. So those four environmental conditions or factors are all influences combined on your overall heat stress that the body can be placed under. If we looked at what types of illnesses that can arise from these heat stress conditions, the first one is very common is a heat rash on various parts of your body where you have a lot of sweating going on, irritation going on. You can develop a rash that is a resultant of the heat. Second is dehydration, where your body is losing bodily fluids, and an ultimate result of that loss of fluids or dehydration is that your body can begin to develop heat cramps, where your muscles will actually start contracting. A lot of times if you watched athletic events, you'll see athletes who are experiencing cramps and go to the sideline, try to get a lot of bodily fluid. Well, that's a result of their bodies being dehydrated and loss of all those vital fluids that creates those heat cramp conditions. And so what they have to do is try to replenish those fluids to address those heat cramp conditions. One of the more serious types of heat stress condition is what we refer to as heat exhaustion. In heat exhaustion, what happens is your body is losing lots of fluids. Usually an individual will have profuse sweating, and eventually if that continues on, they'll start to feel a little dizzy, disoriented. They have a tendency to turn clammy or pale in appearance. And you can tell the people who are starting to develop these heat exhaustion types of condition just from how they react. You can recognize that they're not functioning normally. And the final type of heat stress is the most severe, most deadly, is going to be heat stroke. And that happens, it can happen in a sequence from the heat exhaustion developing into heat stroke, or a person can go right into a heat stroke condition. And basically what happens here is your body's metabolic system just totally shuts down. Your thermal regulators shut down. And that individual will start turning red. There's no sweating involved, and they'll totally be disoriented if they don't become unconscious. And whenever you get to the heat stroke condition, what is happening, because the body thermoregulatory system is shut down, the internal body core temperatures are going to begin to rise. And it's imperative that you immediately get these people to medical help. If you're close enough to a medical facility, a hospital or urgent care center, you should try to get them directly there. Don't try to do the first aid measures. If you are out in an isolated area, then there are some first aid measures you can take as far as, and basically those measures are trying to do whatever you can to cool that body down and deal with whatever the symptoms are that they are having. But it is paramount that on heat stroke conditions that you rapidly get that individual into a healthcare facility. So again, if you look at signs and symptoms of the three types of heat stress or strain, heat exhaustion, you're going to have, again, profuse sweating, weakness, rapid pulse, dizziness, nausea, headachy. The skin's going to be cool, pale, clammy, and the body temperature is actually going to be either normal or a little subnormal. Heat cramps, it's going to be involuntary or voluntary spasming of the muscles, and usually as a result of strenuous exercise or physical work. and then in heat stroke that the sweating mechanism stops, and the skin is going to be hot and dry and flushed, and the person is going to be totally disoriented. The body temperature is going to rise. Essentially what will happen, it'll cook the body organs inside if those temperatures are not controlled fairly rapidly. Well, if we looked at what kind of standards and guidelines, you would find in the OSHA regulation there are no standards for heat stress condition. The reason being is that we will talk about some recommended standards, but because of the variables that are involved as far as conditions that create heat stress environments, it's too difficult for OSHA to regulate. And so what we do is they do put out guidelines and recommendations for people to regulate their work and regulate activity to try to control heat stress conditions. And NIOSH does have a recommended standard. It was published in 1977 and again revised in 1986 that they did have some recommended exposure limits and action levels for heat. Basically, the recommended alert limit is what they referred to as it, is that if you're a non-acclimated worker, then you need to make sure that those workers become acclimated and try to keep them in work environments that are not extremely excessive as far as the ambient temperature ranges. They say try to get these people to work or let them work in temperature ranges from 95 to 103 until they become acclimated. And then the recommended exposure limit that they have, again, you need to concentrate on acclimatization. Acclimatization takes approximately 2 weeks for a worker to become accustomed to working in the high temperatures. And then again, you have some ceiling limits established for when they can work from 93 degrees to 103 degrees Fahrenheit. Now, the American Conference of Governmental Industrial Hygienists, the ACGIH, published TLVs for heat, and again, these are recommended guidelines, and basically what they consider is the overall environmental factors, and they address these environmental factors and have developed what is referred to as the WBGT, which is a wet bulb globe temperature. Wet bulb globe temperature. And in a moment I'll explain in detail what that temperature index involves. But ACGIH also talks about the type of clothing that should be worn when you're working in hot environments. It addresses acclimatization, that any time a worker is coming new, they need to be given a time period to become acclimated. And this comes into effect as when a worker comes off of vacation, because oftentimes their body can become unacclimated and they need to reestablish that acclimatization. And what ACGIH does is they've established, based on the workload, a work-rest regime schedule. And so what they do is they determine a wet bulb globe temperature by measuring the four factors that contribute, the environmental factors that contribute to heat stress. And that is the ambient temperature, the radiant heat load, wind speed, and humidity. And so what they do is use 3 thermometer readings, and the thermometers are set up in different configurations to be able to account for those different temperatures. And on their slide here, we can see on the far right, we see just a regular thermometer. That's going to measure our ambient temperature of what it is outdoors. The thermometer on the left, you can see that the bulb of that thermometer is submerged inside of a black globe. It's just a small little ball, hollow ball, and it's painted black. And this temperature is going to be reflective of the radiant heat load. That's the heat load that is contributed by the sunlight. And so because of the black globe, it's going to absorb that energy from the radiant heat, and therefore that temperature on that thermometer will rise proportionally above what your ambient temperature would be. And then finally, in the center thermometer, you can see it's submerged, the bulb of that thermometer is submerged in a liquid. It's usually just a distilled water, and there's a wick on the bottom of that. That a wick extends up, and what this thermometer is going to factor in is your airspeed and humidity. And the more airspeed you got blowing across that wicked up water is going to drop that temperature. And so what they do is have two criteria then for the WBGT value, the temperature value. One is for outdoors and one is for indoors. And what you do is you can see in this formula that the WBGT in the outdoors is going to equal 0.7 times the wet bulb temperature, which is your center temperature that's factoring in air temperature or air wind speed and humidity, plus 0.2 times the globe temperature, which is the radiant heat load, and then finally plus 0.1 times the dry bulb, and the dry bulb is your ambient temperature. So for the indoor temperatures, what we do is we modify that formula slightly. We only use the wet bulb and globe temperature in calculating out the WBGT. Then they have a TLV table, and this is what the table looks like. It's basically in degrees Fahrenheit, and it's assuming no protective clothing. And across the top of the chart you can see here, we factor in the workload, light or a moderate or a heavy workload or extremely heavy workload. And they give some discussion of what is a light workload, which is not very strenuous, a moderate, maybe something like a simple shoveling, where heavy could be using an axe or pick, or extreme physical activity. And then finally very heavy likewise is even the maximum amount of physical workload. And then on the vertical axis on the left column, you can see a work-rest regime. And 100% means you can work 100% out in that environment, doing that workload that's listed here without any kind of rest. And then as it gets hotter and the WBGT value increases, then your work-rest regime will adjust. It goes from 75% work to 25% rest, then 50% work-rest, and then finally 25% work and 75% work rest. And so, in other words, if you were at that maximum there, you could work 15 minutes, then you got to rest 45 minutes. And during those rest periods, you need to be outside or away from the ambient conditions that are creating those heat stress environments. And you can see here the values. These are WBGT values. They're not your ambient temperature values. So you take that WBGT value that you get from your three thermometers and utilizing that formula, and you can see here the light work, that range goes from 85 up to 90.5. Moderate range goes from 81.5 up to 87.8. And heavy work goes from 78 up to 86. And then finally, the heaviest type of work goes from 81 to 85. Now, I'd mentioned these are recommended guidelines. And the reason being is that we did some studies years ago when I worked for the utility company. We did extensive measurement WBGT values for outdoor workers, our utility linemen, during the summer months. And we recorded those for several days, periods. And essentially what we found out is that if we took those WBGT values and applied this table that's recommended by ACGIH, is that essentially we wouldn't be able to work outdoors at all. And that's why we don't see OSHA regulating this, is because in the Southwest, those areas where you get extremely high temperature and low humidity, it just throws these tables out of whack and they can't be used, because essentially you would say we can't do any work outdoors. Well, if we look at some examples of outdoors work on a hot day, a hot dry day, 10% humidity, on a breezy day, you might get these types of measurements. We got a dry bulb of about 105. Our globe temperature would be 114. You can notice that that's because the radiant heat load is adding to that normal ambient load. And our wet bulb temperature, because we have low humidity and some light breeze going on, is very low, it's 67. So the type of work, let's just say, is moderately strenuous manual labor. We wanted to figure out what our WGT value would be. In this case, if we plugged it into that formula and you did the math, you would find out it'd be 80.2 WBGT. So if we change those scenarios a little bit, with 35% humidity, with no breeze, we can see our values would change. And our ultimate TLV calculation for the WBGT is going to be 93.5. So it's a pretty significant number. And that's basically the primary influence there, is the airspeed and the humidity affecting that value. Again, on WBGT values, much like we can on chemical concentrations, because we go throughout the day and those values will change as the ambient temperature changes throughout the day. We can use a calculated time-weighted average with the WBGT formula, as illustrated here on the top line, where the recorded value for a certain time period times that time period, add that to your second time period multiplied times its WBGT, and so on, however many time periods you have, and you would come up with your overall calculated 8-hour or whatever time period you are calculating out. So if we looked at a problem again and we got a worker with an 8-hour WGT exposure, his profile looks like 2 hours at 31 degrees C, 4 hours 29 degrees C, 1 hour at 32 degrees C, and an hour at 27 degrees C. We want to calculate out that exposure. Again, we put it into our formula and we see that the WGT value would be, in this case, recorded in Celsius with the 30.3 Celsius. Now, if you want to convert that to Fahrenheit, there is a formula for converting back and forth between Celsius and Fahrenheit. Well, if we looked at controls for heat stress conditions and broke it down into our standard source path receiver, you can see here on this table, again, we can start listing the different types of controls that we have available to us to prevent heat stress conditions. On the left, under source is using barriers to protect yourself from the direct sunlight exposure. Or we can change the source in some cases if we're dealing with a source from the indoors. Likewise, we can put up devices on an indoor source of heat to reflect that heat. As far as the pathway between the source and the receiver, again, putting up barriers, put in air handlers, air movers. We can use monitors for the temperature and humidity. And then finally, at the receiver, we can do acclimation, monitoring their temperatures. We can monitor their body core temperatures. And there are some references out there that says if your body core temperature rises a certain level, then a person needs to be taken out of that work environment until that body core temperature reduces back to normal. We can make sure that we have some kind of fluid replacement program, make sure the workers are afforded water. You can use electrolyte drinks if you want, although studies have shown those supplemental drinks are no better or no worse than strictly consumption of water. But if it makes people drink more, then they're fine to use. And then training and education of the worker is important. If we can increase our distance between ourselves and the source of the heat, that will reduce the overall effective temperature that we perceive. And we can, again, regulate the time periods of our exposure, utilizing work-rest regime. Oftentimes, workers who are working in hot environments will implement a work-rest regime just on how what their body is telling them, how they feel. In other words, if they feel like they're starting to get hot and tired, they need some fluids, they can get out and naturally take a break and rest. We do recommend that you try to do your rest regime in an area that has conditioned air of some type, so it totally gets them out of the hot environment. I worked on a project. This is kind of a funny little story. I worked on a project out here at the Polytech site back when it was a military base and it was just closing down. And the project I was working on was doing industrial hygiene monitoring for workers who were going to be drilling holes in a section of the fuel storage tank area, and they were going to implant bacteria into the soils down into the groundwater to be able to eat some of the hydrocarbon plume that was on the water table, and that plume was a result of the fuel storage tanks leaking. So anyway, this particular job was administered by the Army Corps of Engineers, and the contractors that were awarded the job, one individual was out of Ohio, I think the Cleveland area, and he was the one who was representing the people with the technology of the bugs, the biobugs. And then we had the actual construction contractor who was going to do the drilling and the manual labor for setting up this project. That contractor came out of Utah. Both environments are extremely different than Arizona temperatures. And so when the job first began, it started around February, March time frame, and it was going to take about a 4 to 6 month time period to do the job. And as it got nearer to the warmer weather, I did a training class on heat stress, and I emphasized to them to make sure that they become acclimated and taught them about the signs and symptoms of heat stress condition. I also told them about making sure they take adequate fluids. These workers were going to have to wear personal protective equipment. So I explained to them the additional body burden that equipment was going to have on them in performing their work. I said to make sure that you eat good, healthy food. Try to avoid drinking alcohol. Stay away from greasy foods. Eat fruits, vegetables, and make sure your body's got a good intake of nutrients. And make sure that you get adequate rest before each workday and everything. And so I thought I did a pretty good job in that training session. And then once the temperatures started getting extremely higher, we moved the work shift to start a little bit earlier in the day. It was starting around 6 o'clock. And when I was waiting for the contractors to show up, they showed up a little bit late. They finally got there around 6:30. But when they got out of the vehicles, the contractors, I could tell that they had just experienced a late night out. and probably had consumed large quantities of alcohol, and come to find out that that's in fact what they did do. They had frequented a nightclub that had adult entertainment for them, and managed to consume large quantities of beer, in this case, until 1 and 2 in the evening, and then had to get up at 6:30 and come to work. Well, obviously they were not in great shape, and so as they put on their personal protective equipment and they went in and worked that first half a day, we didn't get a lot accomplished. You could tell that they were moving quite slow. I kept an eye on them to make sure that they weren't getting themselves into grave danger. At lunchtime, they went to the trailer, which was air conditioned, and they sent the youngest junior person on the team down to the burger hut and got some greasy hamburgers and greasy fries. And as I was sitting there eating my salad and apple, I was wondering, what did they not get when I talked to them about the training, during the training session, about some of those factors to prevent heat stress, such as reduced consumption of alcohol and getting good rest and eating and drinking the proper fluids. So obviously some people, it's a little more difficult to get the message across to. But anyway, we did survive eventually on that particular job because we were in personal protective equipment. Essentially what we had to do is change our work shifts to the night hours. So we started at 10 o'clock at night and worked up to 6 in the morning, which that in itself created some problems because now we had to have supplemental lighting to be able to see and prevent accidents from inadequate lighting conditions. So anyway, there's always a challenge no matter what you do. Well, in Arizona, we don't have too many situations where we have cold stress environments, but again, they can occur, and especially in jobs like if you're working in Alaska and so on. I worked when I was in the military at the Upper Peninsula of Michigan, which is right along the Canadian border. And there's about 8 months of winter up there, but during the coldest spells of winter, January and February, and even sometimes into March, you can get some extremely cold temperatures that you have to be aware of. But you do have some work environments where you can also encounter cold stress conditions. And here's a list of a few of those, like meat packers and butchers and produce warehouses, ice houses, cryogenics, laboratories, and then obviously the outdoor work in cold temperature. Well, when we talked about the heat indexes for measuring hot temperatures, we also have a cold temperature index, and we refer to that as the wind chill. And on the wind chill, basically what we factor in is the ambient temperature and the wind speed. So those are the only two critical environmental factors that are going to impact that wind chill factor. And so the effects that cold can have, basically the very first thing is your body will start shivering, and that's just a natural warming mechanism the body goes through. Your brain senses that your extremities are starting to get cold, and that shivering is the metabolic way to generate heat in your body. And so your body naturally is trying to warm yourself up. And as you are continuing to experience those cold environments, eventually you can get into a state called hypothermia. And that's basically your systemic cold stress. Similar to what a heat stress is, hypothermia is going to be your cold stress. One of your first parts of your body that are going to be impacted are your hands and feet, your extremities. And the reason being is that the blood in your body is going to focus circulation around your internal body core temperature. And when we talk about the body core, what we're referring to is the body organs that are located between your shoulders and your hip area. Those are your critical body organs, and so your brain's going to tell your blood flow or make the blood flow focus towards keeping those body organs warm. As a result of that, you don't have as much blood flow in your extremities, in your fingers and toes, and so that's where you start feeling the tingling from the cold, and eventually you can develop frostbite. And if that continues for long periods of time, that can ultimately result in your loss of those extremities. Trench foot is another symptom, as well as Raynaud's syndrome, which is more associated with a vibration, or called white finger disease. It can also occur in our cold stress conditions. So again, hypothermia is basically a result of when the body loses the heat faster than it can produce it or generate it metabolically. Our hands and feet are going to be the first thing that are affected. The next thing you'll see is that it's going to have an impact on speech difficulty, loss of your manual dexterity. It'll be hard to perform tasks, for example, with your hands. Eventually what you can do is just kind of collapse or go into somewhat like a coma, go to sleep, and eventually die. Now your hands and feet can drop 40 to 50 degrees below the normal body temperature and not experience any long-lasting effect or harm, as long as that doesn't occur for long periods of time. But your body core temperature, once it starts dropping 3.5 degrees Fahrenheit, that's when shivering will start, and that's when things start beginning to become confusing and be disoriented, and you're less effective in what you're able to do. And again, if you don't get out of those conditions, it can lead to death. Well, like heat, there are some cold or wind chill indexes that are used. The U.S. Army has a table on cold stress. We use this table in the military and the Air Force. What you do is you monitor the ambient temperature, and you do this with any standard thermometer, and then you monitor the wind speed, and you use any kind of velometer that you have, and that will measure wind temperature, and you combine those two factors, and you can then have a table that is essentially the effective temperature. And so you look at this table here, what we see is we've got our air temperature either in Fahrenheit or centigrade, and on this column we have the wind speed. And so by knowing what our wind speed is and our temperature, we can go across this table, and it depending on what section you fall in, it will tell you what your consequences are and what you need to do about it. So in this first section here, which is the first white section you see here, if your wind chill factor falls in that, you can see there creates very little danger. Exposure, if your exposures with dry skin are less than 60 minutes, you do want to avoid any kind of false sense of security. If you start noticing any signs and symptoms, you want to take appropriate action, because everybody's going to act a little bit different. Their body's going to respond a little bit different. But as we go on into the second quadrant here, which is in the purple shading, if our wind chill factor falls into this category, then the danger is increased. That anytime you have exposed flesh, that it could freeze and damage could begin to occur within a minute or so. And then finally up here in our largest, highest category, gives us the greatest level of danger. And you can see here, if you have exposed flesh here, greater than 30 seconds, you can begin developing damage to those areas of the body. So when I was in the military stationed up in the Upper Peninsula, Michigan during winter months, we would monitor these temperature, both the ambient temperature and wind speed, and check our charts. And then we had certain warning signals on the base if we were in a condition where we had to advise people don't go outdoors unless you're fully protected and there's no exposed skin and so on. So that's how we would go about implementing those controls. Again, by breaking down our control measures into our source path receiver diagram, again, our barrier at the source of cold, we can use barriers and changing the source, eliminating that cold environment. In the pathway, again, we can use barriers, monitoring of the wind and the temperatures. And then finally at the receiver, make sure that we have appropriate clothing, dry clothing. Again, we want to try to do acclimation, making sure that people are physically in good shape. We want to do fluid replacements and training. Education and training are paramount. And then if we have to regulate the exposure times. And then whenever we're having people get out of the cold environments for rest periods and so on, we want to do it this time in heated environments, away from those cold elements. So that's the lecture portion of the temperature extremes. Again, in the course of your work, you may have the opportunities to encounter either one of those conditions, depending on where you're located and where your work is located in the environment. And if you do, make sure that you follow your control measures. They're pretty simple, pretty common sense, and by doing so you can avoid these heat stress or cold stress conditions. And you should not only utilize these controls while you're working on the job, but also in your personal life when you're out being potentially exposed and partaking in your hobbies or your activities that you enjoy doing. Just be aware of cold environments and heat environments. So that'll enter in our lecture for this session. I hope you have a good day.